This lesson is an overview of containers and layout managers. In the previous lessons, we've been using a flow layout manager and a panel container to position and display components in a window. So you should have a fair idea of what's going on and how these guys work. But let me give you a quick rundown just to make sure we're on the same page. This is a very brief look at the purpose of a container. The most fundamental task of a container is to maintain a list of displayable components. A container is also a component, so it has a paint method and can display itself in a window. But the primary purpose of a container is to keep its own internal list of components and then put them on display when instructed to do so. It is the container's job to detect incoming events and pass them on to the correct component in its list. The container knows the size and position of each of its components when they are on display, so you move the mouse into a window of the container and click the mouse button. It's the container that gets the event. The container then figures out which of the components is being displayed at that position and passes the event on to it. If, for example, a container is displaying a group of buttons, only the button under the mouse pointer at the time of the click will get the event. If there is no component under the mouse pointer that has been enabled to receive events, then the event is simply discarded. A container is also a component, and like all components, it has a paint method. And also, like all components, the paint method is called with a graphics object when the time has come for the container component to display itself. It may have a background color or something else to display, and then it uses the window information passed to it in the graphics object to create a graphics object for each of its contained components. This new graphics object contains information on just the area of the window that component is responsible for painting, and each contained component is called, in turn, to paint its area. Another job of the container is to lay out the components in the window, but it hires someone else to do this job. The container also contains a layout manager object, and it's the layout manager that analyzes the list of components and figures out how big each one should be and where it should go. A container is never without a default layout manager. Whenever a container is constructed, it immediately constructs itself a layout manager, which it keeps on hand in case the occasion arises that it may need to position components for display. Different containers have different default layout managers. For example, the panel containers we've been using for examples in the preceding chapter uses the flow layout manager as its default. It's kind of an odd layout manager, but don't worry. We've got some that are a lot better, and you can always change the layout manager in a container. That's what we're going to be doing in the next few lessons. The upcoming examples demonstrate rules and options for different layout managers. Each layout manager has a standard set of methods that can be called to control it, but each one uses its own set of internal rules to size and position the components. Before the layout manager can begin any calculations, it must have the size information on each component. So it asks each component how big it is. It asks three questions. What is the smallest size you can be? What is the largest size you can be? And what is your best size? For some components, all three of these are the same. For some, only two will be the same. For example, a button may have a huge maximum size, larger than the screen, but its favorite and minimum sizes could be the same, and that could be determined by the size of the text it displays. And you know how the button can figure that out by looking at the font and the text for the font metrics object. Anyway, once all the sizes are determined, the layout is determined according to the rules inside the layout manager. It comes up with three pieces of size information for its container. What is the smallest size it can be? What is the largest size it can be? And what is its best size? Remember, the container is also a component, so it needs to be able to report these values to its container. Then comes the command from above, which tells your container how big it's actually going to be. You remember how the size thing worked. When the window was first being popped up, the top-level window generally let the container have its own way, and the top-level window sized itself to accommodate the container's favorite size. On the other hand, if you just resize the window with a mouse, this larger or smaller size is dictatorially sent to the container and to the layout manager, and the layout manager is instructed to make everything fit that new size. If you made the window too small, some of it will get chopped off, and you'll have to stretch the window out again to get it all back. But the layout manager did its best to follow the instructions. Okay, I know I've left out some details, but instead of filling in the blanks right now, let me just show you how to use the various layout managers to build windows. Then we'll go on to build a custom layout manager, and that should clear up your questions.